A batsman makes a score of 20 runs in his last match and increases his average from 10 to 12. Find the total number of matches that he played. So a batsman scores 20 runs in his last match. So in his last match alone he made 20 runs. So before his last match, assume that initially he played n games and his average was 10. So on an average he scored 10 runs. So 10n is the total number of runs that he made in the first n matches. That is n matches into their average 10. This will be the total runs. That is, we have the basic formula. Average is equal to sum of all the numbers divided by number of numbers. So total sum is equal to number of numbers into their average. So n matches into their average 10. So this is a total sum of all the runs that he has made in the first n matches plus 20 that he has made in his last match. So this is a total runs that he has made divided by number of matches, that is n plus 1. Initially n matches, and in his next match, that is the last match, he has scored 20, that is the n plus first match. So total runs by number of matches n plus 1. This average is now equal to 12. Earlier it was 10. After scoring 20 in his last match, his average has now increased to 12. N plus 1 is the total number of matches that he has played, and that is a value that we need to find out. So let us just solve this equation. I'll bring n plus 1 to this side. So 12n plus 12. I'll bring 10n to this side. So 12n minus 10n, that is 2n is equal to 20 minus 12, that is 8, or n is equal to 4. So n is the initial number of matches that he has played, and then he scores 20 runs in his next match. So total number of matches is n plus 1, that is equal to 5. So altogether he has played 5 matches. Hence option B is the right answer. A jar contains a mixture of two liquids A and B in the ratio 5:1. So a mixture of two liquids A and B, and they are in the ratio 5:1. So you can take it as 5x and 1x. So you can form the equation like this. That is 5x plus 1x total is equal to 6x. So if the total quantity of the mixture is 6x, that will contain 5x of A and 1x of B. Now 12 liters of the mixture was taken out. So we will see what has happened when 12 liters of the mixture is taken out or when it is removed. Now if you take out 6 liters, it will have exactly 5 liters of A and 1 liter of B. So if the total quantity is 6x, that will contain 5x of A and 1x of B. Similarly, if you take out 6 liters, that will contain 5 of A and 1 of B. That ratio will always be maintained. Similarly, if you take out 60 liters, that will contain 50 liters of A and 10 liters of B. So 50 plus 10, it is 60. So this ratio will always be maintained. Similarly, if you take out 12 liters, instead of 6, if you double it to 12, the quantity of A and B will also be doubled, so that the ratio is maintained. So 12 liters of the mixture will contain here 10 liters of A and 2 liters of B. So that 10 plus 2, it is 12. So if you take out 12 liters, it will contain 10 liters of A and 2 liters of B. Now assume that the initial quantity is 6x. If you assume that the initial quantity of the mixture is 6x, A will be 5x and B will be x. Now 12 liters is taken out. So we will see what will happen when 12 liters is taken out. 12 liters contains 10 liters of A. So 10 liters of A is removed and 2 liters of B is removed. Taken out the same as removed. That is 12 liters will contain 10 liters of A. So effectively 10 liters of A has been removed and 2 liters of B has been removed. So this is the situation after removing 12 liters of the mixture. And 4 liters of B was added. So now an additional 4 has been added. So we have assumed that initially b was x and now it has become x minus 2 plus 4. So that is effectively x plus 2. So initially b was x and now it has become x plus 2. So effectively there is a 2 liter increase for b. So what is the net change in liquid B? So there's a 2 liter increase. So option B is the right answer. A person can row a certain distance downstream in 6 hours. So let us form the equation for that. You have the basic formula, distance by speed gives you time. So this is a basic formula. He can row a certain distance. So distance we'll take it as d. Now when he is going downstream, effective velocity will be b plus r, where b is the speed of the boat in still water and r is the speed of the river, and the time required is given as 6 hours. So distance by effective velocity b plus r, that time is given as 6 hours. So this is the equation for downstreaming, and returns the same distance in 9 hours. So distance is same d, and when he is returning it will be upstreaming and effective velocity b minus r, and the time required is now 9 hours. So this is the equation for upstreaming. B is the speed of the boat in still water and r is the speed of the river. If his speed in still water is 12 kilometers per hour, so b is equal to 12 kilometers per hour. So let us substitute b is equal to 12. D by b is 12 plus r is equal to 6, and for upstreaming d by b is equal to 12 minus r is equal to 9. So you have these two equations. So let us eliminate d and calculate the value of r. Find the speed of the river, that is r. So here d is equal to 6 times 12 plus r, and here d is equal to 9 times 12 minus r. Here 3 divides 2 times, here 3 divides 3 times. I'll take 2 inside, so 12 into 2, 24 plus 2r is equal to 3 into 12, 36 minus 3r. I'll just write it down here. I'll bring 3r to this side, so that will be 5r is equal to 36 minus 24, 12. So r is equal to 12 by 5, that is 24 by 10, that is 2.4 kilometers per hour. So find the speed of the river. R is equal to 2.4 kilometers per hour, option A. A train traveling at 90 kilometers per hour crosses a bridge in 6 seconds. So let us form the equation for that. We can draw the bridge like this, and the train is here. So the train is just about to enter the bridge. Now to cross the bridge, first the length of the bridge has to be crossed. So assume that the length of the bridge is b, and assume that the length of the train is L. So first the length of the bridge has to be crossed, then the train will be here, then its own body length L. So b plus L, that is the distance to be moved to cross the bridge. So distance is b plus its own body length L, and the speed of the train is 90 kilometers per hour, and the time required is 6 seconds. So this is the equation that you get. Now we'll convert 90 kilometers per hour into meters per second. We'll multiply by 5 by 18. So let us calculate the value of b plus L. Here 9 divides 10 times, here 9 divides 2 times, and 2 divides 5 times, from which you will get b plus L to be 5 into 5 25, 25 into 6 150. So b plus L is 150. Now the second situation is that what is the time taken by another train 100 meters shorter, traveling at 45 kilometers per hour to cross the bridge. To cross the bridge, first the length of the bridge has to be moved, then its own body length, and that body length is L minus 100. So because it is 100 meters shorter, so this is the distance to be moved, divided by its speed is 45. We'll convert into meters per second, multiply by 5 by 18. So this is what we need to find out. Now from the earlier equation we know B plus L is equal to 150. So substituting 150 here, 150 minus 100, you will get it as 50 by 45 into 5 by 18. Here 9 divides 5 times, here 9 divides 2 times. So 5 into 5, 25. 25 by 2 gives you 12.5. So this will be 50 by 12.5. You will get it as 4 seconds. So that is the time required for the second train to cross the bridge. 4 seconds. That is option A. The daily wages of a person was decreased by 30%, and he now gets rupees 21 per day. What was his daily wage before the decrease? So we will assume that the original daily wages were rupees X per day, and it was decreased by 30%. It was decreased by 30% means now he gets only 70% of what he used to get. That is, if you decrease a value by 10%, you will be getting only 90% of that. If you decrease a value by 20%, you will be getting only 80% of that. Similarly, if you decrease a value by 30%, you will now get only 70% of that. So now you are getting only 70% of the original value, and what you are getting now is rupees 21. So let us solve and calculate the value of X. X is the original daily wage before the decrease. I'll cancel out 1 0 here. 7 divides 3 times. So you will get X is equal to 10 into 3, 30. So 30 was the original daily wage before the decrease. That is option A, 30.